Okay, well, hello. Welcome to this random Sunday stream, which is sponsored by my ADHD. Yeah, this is a surprise for me too. I did not expect to stream on a Sunday and this early, and I don't even know if it will be a long stream even. But here's the thing, I essentially just opened Unity because I was annoyed thinking about the lagging with the new mesh creation from yesterday's stream, and I wanted to fix that. And as I was going through my code and Joyce's code, I started doing things, and as I was setting up the compute buffers and the compute shaders, I was like, you know what, I might I wouldn't want to try it out and then do it all again for the stream. So I was like, you know what, I'll just stream whatever the hell I'm doing right now, and even if not many people join due to the randomness of the stream's time and schedule and whatnot, at least it will be recorded and uploaded. Hey Mathis, welcome. So yeah, oops, sorry about that. Yeah, so yeah, I was kinda... So the issue yesterday, just to do a small recap, was that, okay, we set up like this nice editing stuff to add like different types of grass and all that crap, so all that's in, that's looking good and great, and we have the points and erasing and undoing and all that stuff. That's in, that's cool. But I was following the same process that Joyce's grass rendering does, which is like generating a mesh and then passing out that mesh onto a compute shader and then generating the new triangles and all that. But the thing is that I tried like making and updating the mesh with every instance, with every spawn point I added, or with every spawn point I removed, and generally, with every update, I recreated the mesh. And that actually caused a lot of lag. Now, the irony of this is that when I opened the project again today, it wasn't lagging. So I don't know if it was like, accumulated garbage, like on my computer or on the project, or I don't know what. But it wasn't lagging. But never mind that, I realized that I actually don't need to generate the mesh. Probably that was a residue from Joyce's previous system that used geometry shaders, which you would actually need the mesh. But I mean, the mesh is created and then the data Yeah, maybe a memory leak. Probably, I mean, yeah, could be that too. So the mesh was created, and then, you know, we passed the data of each vertex onto like a struct and moved that over to the compute shader. So we didn't really need to make the mesh. If we can just pass over all the data to the compute shader, then it should work. And the fun thing was, as I was trying out some stuff yesterday with trying to add some burst stuff and all that, I converted the spawn data class to a struct and nothing broke, because I don't use it as a nullable reference type anywhere, so that was cool. And I thought, you know what, since I have that as a struct, might as well, you know, just use that over to the compute shader. So that's what I did. Some stuff are wrong though, I'm just realizing that. Because these stuff should be in object space, but I'm actually storing them in world space. So I need to make some sort of little transformation when I'm adding them and when I'm getting them. So that's what I'm gonna do. So when I am adding the spawn point, before I add it here, I can go over and say, hey, you know what, that position you have here, make it like local space. So follow that position. Yeah. And you know what, do the same with the normal. Whoa, direction. Yeah. And then throw it in. But when I want to actually remove it, actually no, that's good. So I'm adding that, but when I want to remove stuff from when I'm erasing with like the brush, is my grass paintable? Yeah. That's the point. That's the whole thing happening here with this. So actually now, technically, if I move this, nothing happens. That actually makes sense. Yeah, it does make sense. It does make sense. I'll get back to that. Give me 1 second. Here in the green, when I want to remove that, no, not that. Remove the spawn point. This adds the spawn points. I want to remove the spawn points. Oh, also use that. Then I can go back and update data when I'm adding things, which makes more sense. I guess maybe I'll come back to that, whatever. But yeah, here, instead of this, I need to say something like the Greenery manager transform point. So I need to bring this back to world space, or I could bring the hit point back to object space. No, I think that's better because the radius would be better, would work better. Is the grass attached to the ground in any sense? Like, does it move with it? It doesn't move with the ground, no, but the thing is that supposedly, and I will make sure of that right now, the positions are stored in local space in relation to the manager, like the one that the one object that stores all the renderers. So you could move, if you wanted to move like all the grass, but like all of them, you could move the manager along with like the terrain. But you could, if you wanted, I could, and maybe putting it on a backlog as a potential feature, maybe optional, I don't know. But you could make it move to the ground if when adding the spawn point, I also added the transform which I hit when I painted that. So I could use those coordinates, like that space, to transform back and forth. So this supposedly should be transform point, because that position again is in local space. And transform point. You know what? This. And you know what? Transform that. Can you not? Seriously, can you, like, not make me do this? Oh, and this? Yeah, sure. Why not? Just gizmos. Okay, let's clear everything. Whoa! Oh yeah, yeah, okay, don't worry about this for now. I added the code to instantiate the compute shader on the renderer, but I don't need that for now. Yeah, that's like the standard error we get. Okay, so now technically, if I actually move the manager, yeah, these move as well. Because you can see I'm adding them in walled space, like, you know, I'm painting, or you know what, for the sake of argument, if I move this over here and I paint here, yeah, that's not how it's supposed to look. Also, I'm still lagging. That could be because of the stream? I wouldn't want that to be the case. Okay. So it's not working great exactly. Let me see why. So when I'm painting an object, new spawn point with spawn hit point, spawn hit normal. When I'm adding these points here, oh damn, that was the wrong thing. Okay, let's try this out again. Spawning here, moving the manager, spawning here, there we go. So you can see they all act in walled space when I'm painting them, but as they're being added, they essentially get parented to the Greenery manager. So if I move those, they move along, but again I can paint whenever I want. Also, that's the case for rotating. They rotate around the pivot, and again I can paint here, there we go, and this still goes here, so that's all good. Still lagging a lot, that's weird, but yeah, we'll go back to that. And also that's also the case for scaling. Do keep in mind that this is actually scaling the position, so you know they're being distanced from the pivot based on the scale. That wouldn't necessarily mean, unless I made it so, that it's scaling the grass blades itself. Alright, alright. Okay, oh freaking hell, okay. Alright. Sorry, just some weird Discord messages. Anyway, oh, thanks, Mathis. Okay. So these are now in object space as I'm passing them along, so that is good. Going back to our renderer now. I want to create the compute shader here. And yeah, as I mentioned, I started making some setup about the compute stuff. And that was the point where I realized that, hey, I should be streaming this because it's interesting. It's compute shaders. So didn't do anything crazy right now. I just added the compute buffers that I want, which is the spawn data buffer, which is fun because I already have like the spawn data structure and the list, so I can just put it in. So I just have like one collection to manage. Ideally that will work. We'll see. And I've set it up to be like a sequential struct layout so that I can also pass it as is over to the compute shader, hopefully. Rendering, the draw buffer, which is gonna be the buffer where I get back my triangles. Right now I want to try, if I manage to get one triangle from each spawn point, I will be happy and I will end the stream there. Or if the stream takes too long, I mean, I won't be streaming until I get a triangle. That might be a suicide mission. I have the indirect arguments buffer, which is like needed for drawing instances. It's like it's basically an arguments buffer that says, hey, draw this many of this mess, and each of those mess is gonna have this many vertices, stuff like that. So yeah, this is usually like pretty boilerplate, but we'll be doing some stuff in it in the compute shader land. This is essentially how the indirect arguments is being initialized, and again some more boilerplate compute buffer shader stuff is setting up the buffers, and also dispose buffer. That's a classic thing that I end up doing when I'm making compute shaders, and I should probably like put it on a library or something, but whatever. So yeah, it takes a compute buffer, and all it does is say, hey, compute buffer release. Nice. Well, if it's not null, release it and then set it to null. And then also release, okay, all this release buffer and then release buffers, which is specifically for all our buffers, and I can just say, hey, you know what, spawn data buffer, no, release buffer, spawn data buffer, release buffer, draw buffer, and release buffer, args buffer. Okay, I'm gonna do it really inefficiently first, where I will just like set up the buffers, draw, release the buffers. But yeah, that's not because the buffers correspond to like the spawn points you have. This is not gonna change if you're not adding or removing. So, you know, on playtime you won't have to set up and release the buffers over and over again. You just have like the buffers and they're there. Haven't you already explored grass shaders? Yeah, I have explored grass shaders a lot. I've explored them in many different ways. The grass shader you probably have seen in my website is a geometry shader. It's not a compute shader. Geometry shaders are super cool, but they are infamously slow. At least nowadays it's a bit better, but they used to be super slow and not preferred. And also there are some compatibility issues. Like I think Mac computers don't support them. So they're kind of a mixed bag, and they're like, I think they were a DirectX thing, like a Microsoft DirectX thing, which was pretty cool, but like they didn't support it enough, or like it, I don't know, people didn't use it enough, maybe because it was slow, so it wasn't like evolved a lot. Supposedly the new kind, the mesh shaders as they call them, is gonna be like the new efficient way of supporting this kind of shader behavior where you actually generate new geometry. But until then, we essentially use compute shaders. We essentially use compute shaders to simulate the effects of geometry shaders. So yeah, that's it. Hey Sizzle Gizzle, what's up? So yeah, that's what I'm doing here essentially. Like all this, if I put that in a mesh, I could use a geometry shader to generate all the triangles I want. But instead I'm gonna use compute shaders to generate that geometry. It's gonna be faster, and then send that over to another shader to actually shade it. Because that's what shaders do, mostly. Okay, so I set up my buffers, I release my buffers, and let's actually do some rendering. Just render. Because it's a renderer, so you know, that's what renderers do, they render. Okay. Let's see. You know what? No worries.
Computers now have primary control of critical vehicle functions.
Yeah, if release buffers, set up buffers. Let's just you know what? Just set up buffers. Yeah, screw that. Okay. Alright, so I have set up my buffers. Now I need to set their data. That's how that works. So arcs buffer, set data to my arcs, indirect args. Oh, I need to set up some bounds. I will do that as well. Oh, there's so much stuff I need to take care of. Okay. Okay. Let's pause this for a minute. Let's go creating the compute shader just so I can see what needs to be done. So I'm gonna make a compute shader, gonna call it, I don't know, triangles CS. It's just gonna output triangles. If that works, then we can move on to more complex geometry. And I actually can put that there. So now clear all points. Yeah, okay. There's a neat bug here that I will need to keep in mind when I try to see something. Okay, so here's the thing. Geometry shaders are like objects. They're not like just shaders. I can't speak words. Okay, they're not like scripts that define an object or something like that. They're kind of like objects themselves. So this is why when I'm creating a renderer, I instantiate it, because when I'm assigning data over to a compute shader, I'm assigning it to that specific compute shader. So if I were using the same compute shader on a different setup, things would get confused because it's like the one compute shader. So in order to combat that, I make an instance of that compute shader locally for that specific renderer, and I set my data over to that. That would mean that if I have created an instance of this compute shader, which I haven't, not this, sorry, this one, which I haven't wrote anything in. So if I make changes here, they won't reflect over to this because I already have an instance of the existing compute shader. That's an easy thing to mess up and be like, why is it not updating? That's why. Okay, I'm gonna call this triangle main. It's gonna be 128. I feel generous today. And remove all that. Now I'm gonna copy stuff and hope they work. Again, I need to reflect the spawn data struct in the same exact manner. So that could be a float-free position it's in object space and a float-free normal in object space. That's what I have right now. I don't have any UVs, I don't have any colors. Maybe I will eventually, but right now I do not. And I have a structured buffer of these spawn data, which is the spawn data buffer. That's easy. The lowercase s. I also have the structs that I will end up outputting. Those will be the same in every Vertex compute shader I write for this system, because at the end of the day I'm writing vertices and triangles. I want the wall space position here for some reason. You know what? I'll put some UVs, we'll improvise there, and a color, again, we'll improvise there. And there's a triangle, that's the star of the show here, triangle, go 3, what has the object space normal for some reason, we'll get back to that. And, sorry, I draw vertex. It has the 3 vertices that compose the triangle because it's a triangle, so 3 vertices, you know how this gets. We're gonna have an append structured buffer of these because we're just gonna append triangles. It's gonna be the draw triangles. Oh, you know what? Let's follow convention. Whoa. Draw. Yeah. And I'm gonna have the structure of the indirect args, which is again pretty boilerplate. The uint num vertices per instance, uint num instances. So how many vertices each instance is gonna have? How many instances I'm gonna have? This is a key one. Where do we begin? Was like the first vertex index that we will begin drawing, and what's the first instance we will begin drawing. So that's why these are set to be 0, because we want to start, from the start essentially. In most cases it's 0. This is gonna be an RW structured buffer, meaning that we will be reading and writing to them. That's buffer. Okay. So we're gonna need some variables also from the renderer. There's a lot of things here in the one that Joyce has shared, but I don't need all that. I need like the most basic of them. So let's start with the number of points I have. So num spawn data. How many spawn data I have? I do need the local to world matrix, which might sound scary, but it's actually not. Since I set my spawn points to be in the local space in relation to the Greenery manager, I also need to pass the local to world matrix of that transform, of the Greenery manager transform, in order to bring them from object space back to world space. Now, if I did it the way I mentioned before, where I could have like I could have the spawn points to be relative to the surface that we spawn them, I could store a matrix, or maybe just the matrix for each spawn point. It would be like maybe both the world to local and both the local to world, or maybe just the local to world, because that's what we need here. Yeah, I could save it parented to that surface, and I could store the local to world matrix of that surface per spawn data and use that. But since we're using like just one object that's like the parent of all instances, I just need the one local to world matrix. I hope that makes sense. And you know what? Let's store the width and height. Width, height. It's gonna be like, it's obviously not gonna be grass. I just need triangles now. I just need to see things working, and we can go from there. And then there's a bunch of other stuff that are here that we don't care about, like wind stuff, blade stuff, fading stuff for LODs. I have here a matrix for frustum culling. I don't care about any of these. So what I do need is some methods here. Especially I want the one that will return me a draw vertex. So I'm gonna call this triangle vertex. I'm taking the object space position, I'm taking the width, I'm taking, do I need the width? I will say no. Let's say no for now. And do I not store the normal? That's odd. Okay, you know what? Let's... Okay, you know what? Let's add the stuff we need. So that would be like a float to UV. Again, we will improvise, and a float 3 color. And we can just say here, we can make a draw vertex output. Let's initialize it to be 0. Whatever that means. Float 3 new. Oh, we're not doing anything with. No, I will add the width and height at the generation. So here I just need to say position world space. It's gonna be multiply the local to world matrix with our position object space position 1, and so that here it's gonna be the UV output color. It's gonna be the color. Hey, I'm an operate. Super simple. Let's dive in the main. So if that's a very important thing to do. I spent a lot of time debugging in Compute Shader because I forgot to check the bounds of the index. because the behavior is like so undefined if you go outside the bounds of your compute shader. Like, I don't know if anybody has watched like Gravity Falls and like the end of it, but like things get this weird if your bounds get outside, if your index gets outside your bounds, sorry. So num spawn data. If we're out of that, please return, please, like please. We get a spawn data, call it ST from spawn data, and we get a spawn data buffer index. Okay, we have our point. Do I need anything else? Like, there's so much stuff happening here, so I don't know if I need to be honest. Vertices per blade. Num blade per vertex. I think I just need to append one triangle for this, because this is now we're just in the domain of one single spawn data point. So it's not like we're looping over all of our points, because that's essentially what the shader does for us. That's the tricky thing to get your mind around when it comes to parallel processing and all that. So I need to output 3 draw vertices. Draw vertices gonna be just 3 of them. All right. Yeah, okay. It's gonna be like super simple. So the draw vertices 0 is gonna be the triangle vertex with the position OS. So we're going counterclockwise. So let's say this is like the bottom left. So it's gonna be the position OS minus the width, triangle width, 0, 0. And you know what, just make it red. I don't know. I know it's grass, but it's supposed to be grass, but I'm making it red. Bear with me. You know what, I will actually add a different color to its vertex, just so we can better debug it, I guess. That makes sense. Okay, this is the right. Hey, Bitter Joy Rock. We are compute shading today. Hopefully. And this is right at the middle and adding the triangle height. So, single triangle. Make it blue. We have our 3 vertices. Now we can make a triangle. Let's initialize it first and just, you know, I haven't seen how does Unreal handle compute shaders? Like, I haven't seen a lot. Well, I haven't worked a lot with Unreal too, but I haven't seen a lot about hand-coded shaders in Unreal. So how do compute shaders look in Unreal? I don't know. I mean, probably they look like that, but what's the setup like? That's what I'm asking. You know, You know, just get the object space normal of that specific spawn point, I guess. Why not? It's normal OS because we're in object space. Yeah. And try vertices. 0 is gonna be, well, guess what? The draw vertices. 0, 1, and 2. Wow. Why does my brain work like that? Jesus. Okay. Thank you. Yeah, and now we can just go and draw triangles. And that's try. And now the cool thing here is looks at all kind of inject them awkwardly into the bubble. Oh, you can access the GPU. That sounds interesting. I thought Niagara, even though it was like wicked fast and all that, I thought they weren't GPU accelerated particles. Am I wrong? I think they were CPU yet, even though they're like super fast. But I might have... Oh, okay, but they used to be CPU, right? Okay, I'm glad that I wasn't mistaken. So this is a cool thing. When we're drawing procedurally, we need the indirect arcs to point to how many instances we're drawing. But since how many vertices and instances, we know the number of instances. We know that from before because we have the spawn data. But we don't, since we're adding the geometry procedurally, we need to update that. So there's this method, it's called interlocked add, which is essentially a thread-safe way to add to a parameter, basically, because, you know, we're threading all over the place and we wouldn't really want to use like a simple plus there. Things would get hairy. So instead, you know, this is just gonna be like, I'm adding the number vertex. I'm adding 3 vertices because I'm making a triangle. Oddly enough, this should be it. This is like our first compute shader that should show us something. Technically. The next, I don't know, 1.5 hours is probably gonna use this exact compute shader and me banging my head against the wall about why it's not working. But the compute shader probably should not change, unless I did something really stupid, which is possible, but I can't see it now. I will see it later, probably. Going back to our greenery render, first off, I want to sanity check my stride sizes. So the spawn data stride, it has like these 2-3 float trees. So it's... Yeah, see, I'm already doing... no, actually, yeah, this is correct. So it's 3 float trees and 3... Yeah, so that's 6. Yeah, that makes sense. Okay. I don't know why I got so confused there. Yeah, alright, that makes sense. The draw stride. Now... The draw stride. Now, I'm not so sure about this. Like, when I'm drawing... Oh! Wait, I think I know why is that. So Oh yeah, I know why it's that. Okay, so my draw struct is a normal vector, so 3 floats, and 3 vertices. Each vertex is a float 3, a float 3, and a float 2. So we have float 3, float 3, float 2, 3 of them, plus the 3 from the normal, multiplied by the size of float. There we go, we have the size of our draw triangles tract. This is why this is like weird looking math, and why I haven't just, you know, added them all together. It's to sanity check that stuff. Direct arcs right, we do know that they're just like 4 integers. That's easy. Cool. Let's see what else we need though, because we need shit. Here's where I'm setting the data on the buffers. So spawn data buffer. Also, let's set our data to the spawn data list. We have it right here. It's so convenient. And here I'm just setting the data. Okay, let's get all the compute shader shit we're gonna need. Kernel ID, which I know it's 0, but you know, let's pretend I don't know that. Rendering CS, get kernel, no, get find kernel, I think it's called triangles main? Triangles main, yeah, just sanity checking. Alright, we have our kernel. Let's get the thread group size, which I know it's 128, but let's pretend I don't know that. Thread group size, it's gonna be rendering CS, get kernel thread group sizes. Oh, actually, I'm not doing it like that. I'm doing it kernel ID out int, sorry, new int thread group size. And guess what? I don't care about this. No, and I don't care about this either. So discard them. We have the thread group sizes. Now, let's set all the shit we need, which is buffer 1. I do want this draw triangles buffer. I do want to mark this as buffer, so cool. Draw triangles buffer, we get that. So it's the 3 buffers and that shit. Let's set these in here. So public float width gonna be 1, I don't care. Public float height gonna be 2, I don't care. And then it's the metrics. Okay, so setting the buffers. Rendering CS, set buffer kernel ID, and where is this setting the buffers? It didn't send buffer. Oh, okay. Is it doing it on enable? It's an interesting choice. Why? It's not doing it anywhere else. No, it's just doing it on enable. Oh, it's because on late update it's doing on disabled and on enable again. So it's getting updated. That's a way. I'm gonna set them here though, just for the sake of clarity. Spawn data buffer. Spawn data buffer and spawn data buffer. Rendering CS, the buffer, kernel ID. You know what? It's called draw triangles buffer. Draw triangles buffer. Draw triangles buffer. All set. Rendering CS, set buffer, kernel ID. Indirect arcs buffer. Indirect arcs. Wait, no. That's the arcs buffer. No. Indirect arcs buffer. Awesome. Okay, setting the buffers. Next up, spawn num-spawn data, rendering CS, set int. Num-spawn data is gonna be the spawn data list. Nope, spawn data list. Thank you. Count. We know that. Local to world. That's an easy one. Rendering CS, set matrix. Transform. Nope. We have the manager. Green manager. Transform. Local to world matrix. So simple. Triangle width and triangle height. Are those floats? Yeah. Set float. Triangle width. Triangle width is we have the greenery item width. Height. Yeah, alright. Let's go. We have everything here. You know what, just to be certain, we set the counter value of the triangle buffer here. So now, technically, I can dispatch my compute shader. So I can say rendering CS dispatch. That's such an exciting word. Third group's X is gonna be the math. You know what? Still, I need to do this. That's also another way where I bang my head against the wall. The spawn data list count divided by my thread group size and 0, 0 or 1, 1. 1, 1. I set this to be 1, 1, right? Yeah. 1, 1 and make that an int. Cool. Let's first see that it's not blowing up. We won't be able to see anything either way. We're just adding a bunch of triangles on a buffer. But again, these are compute shaders, and if things go wrong, they can blow up my computer. So let's do a quick sanity check. Right now I'm not calling render, so everything should be good. As I mentioned, I have well, alright, see, I already have an issue here because I forgot a semicolon. Position OS. I say positions, that's wrong. Okay, no errors here. As I mentioned, I don't have the correct instance of my compute shader, so I need to clear all the points. So I have destroyed my renderer too. And adding this, ignore that it just likes to spawn that. You know what? I'm tired of this error, so if this is okay, you know what? I'm checking some if spawn list length. Or yeah, just return. Yeah, fuck return. I don't care. Logarithm. Clear points, clear. Okay, no more of this annoying bug. Awesome. Not bug, error, but still awesome. Clearing, making all this. Okay, we have this. Hey, Lasamat. Yeah, I know. Water is usually a Sunday thing, but I'm all out of water shaders. Well, I cannot ever be out of water shaders, to be honest. But right now I'm obsessed with grass, so I'm just doing an exception. Okay, and the Greenery manager supposedly on late update is gonna iterate through all renderers and it's gonna say, hey, you should render. And now the city is about to hit the fan, probably. Let's see. Ideally, we will get absolutely nothing different. And that's the way it should be. Clearing everything. Okay. Nothing is happening. This is good. I cannot stress this enough. This is good. I mean, assuming that we are actually running, we're actually dispatching the compute shader, but I think it should work. Okay. So here's where things get a bit tricky. Okay, I do need to calculate my bounds. To be fair, I already have the minimum and maximum on the Z, so maybe I can actually use those. What can I use for this? Just center and... but I think... encapsulate, and I think I could use this going like a point, right? Or set min max. Boom! Yeah, this is fine. Okay, I can say new float tree min x. Why make it minus? This should be essential, but for now, minus 100 and min z and a new float 3, thank you, of a max x 100 and a max z. So technically now I have my bounds. Maybe. We'll see. If not, there are other ways to find the bounds, but since I already have the min and max because of the cell binning, might as well use them here. Okay, I have the bounds. I need the material. The material will actually be provided in the Greenery item scriptable object, so material. Again, I need plenty of setup to have something up and running, so once again, I'm gonna need to make the shader, but let me find my references. Grass. Grass for compute shader. Yeah. Yeah. Okay. Let's make our shader. Yeah, I'm gonna get lots of those. Trust me, I'll fix them. But the good thing is that the compute shader was running. That's why, or maybe it wasn't. We don't know if it was running or not from these messages. Is what I'm trying to say. Okay, so let's make the shader for the instances. It's gonna be an unlit shader. I'm gonna call it spawn instance shader. Maybe it's gonna be the base for everything we want to make. And you know what? Let's just output the vertex color. But we need to set up the structs first. This is gonna get weird. Shadow stream. Okay. Not doing anything fancy for now, just gonna be unlit, but I just want to see triangles, not gizmos anymore. So I think I need this, but not this, because we're gonna provide our own data. We're gonna have the draw vertex struct, so screen position, wall space, for some reason. I'm not sure why we're doing that in wall space, but let's do more of this for now. And color. This is the draw vertex struct, and we also have the draw triangle. This could also all go onto a CG include file, and we can actually import that over to the compute shader as well, so that we can change it globally. But yeah, normal OS, which isn't really, is it really? Yeah, I guess it is object space. Oh well. And draw vertex vertices, three of them. A structured buffer of the triangles. Draw triangles buffer. Let V2F this is correct. This is correct. Keep the fog. I don't care. I really don't care. And you know what? Color. I really don't care about all the main text stuff. So here's where things making word. Oh, that's interesting. Okay, I'll get back to that. This is what? Point lights. Okay, we're not getting over to lights yet, so I think we should be good just with this. So instead of up data, because as I mentioned, I removed that, we get SV vertex ID. We get the vertex ID here. We do make this the output, that's for sure. And now to get our data, draw triangle, gonna be the draw triangles buffer, vertex ID divided by 3. So what happens here essentially is when I'm creating this geometry, I'm adding triangles, right? I'm adding one triangle and like 1 to 3 vertices, the next triangle 1 to 3 vertices, and so on and so forth. But what goes over to the vertex shader is, well, the vertices, because that's what it is. So I have the vertex ID, which is literally just like the index of the vertex as I'm adding them. So it's gonna be like, it's going from 0 and it's going all the way to the number of vertices I have. So it starts from 0, and the first triangle is 0, 1, 2. Second triangle, 3, 4, 5, so on and so forth. So in order to find which triangle I'm currently drawing, I'm dividing by 3. So if it's the first triangle, I'm dividing 0, 1, 2 by 3. Because it's an integer division, I'm getting 0, and so on and so forth. And in order to find which vertex of that triangle I am outputting, the first, the second, or the third. Thanks for the follow, Lilam21. Yes, input. This is the vertex of the triangle with the ID modded. Anyway, the modulo of the vertex ID with 3. So I always get 0, 1, 2, 0, 1, 2. So it's like the first, the second, or the third vertex of that triangle. Also, this is wrong. This is draw vertex. The reason we're doing it like that is because what we are passing in the vertex header essentially is just the list of the triangles, and the vertices are included in each triangle object. Usually that's not the case. Usually the way that messages get rendered is that, you know, we barf a list of vertices at it, and the triangles have the indices of the vertices. So they say that, you know, this triangle is composed of the vertex with index 54, 55, and 56, but not the actual vertices. Here we're storing the actual vertices inside the triangles. I hope that makes sense. O vertex. So this is a bit weird, but you know what? Again, I'm gonna humor this. It says object to clip pulse, but this is supposed to be input wall space pause. We'll see if this works or not, but I mean, I'm using the code which I've seen works. That's a bit weird, but yeah, whatever. One thing they do is also they transfer the wall space position over to the fragment shader. I'm not currently using that, so I don't think I will be needing that for now. Code 3, do you also need the normal? Do I need the normal? Right now I'm not really using the normal. Oh, you know what? I'm gonna call this V because syntax convention. And no color equals V color. And you know what? Keep your fog. Thanks for the follow, Drew Feeds. Yeah. And V vertex. That's okay, there's this, apparently this is a hack, but apparently this needs to be kind of done. V.vertex, which is, what's V? Transfer vertex to fragment. Do a little copying here because I'm sure that there's a reason this is done like that. You know what? Maybe I will rename this back to input. Oh, this is again, and this is just like for making point light things. So supposedly this should work. If we get weird positioning, I will try to make this walled to clip pose because again, this is supposed to be walled position. So yeah, we'll see about that. But this is supposed to work. Also, I really don't care about this. The color is just gonna be eye color. And technically, that should do it. Technically. Okay, there are some... Yeah, okay. Screw... Oh, I mean, no, dude. Okay. Alright. Let's make a test material of this. We're getting close. But you see how much setup I have to do just to output a single triangle and see it on my screen. And I don't know at which point any of this system is gonna fail me. Like, there's so many different points of failure right here. From my editor script that scatters points, to the manager that creates the renderers, to the compute shaders, to the actual shader, to the scriptable objects. There's so much opportunity for me to screw up. But it's exciting when you see it all come together, and you know, like the Kronk meme. That's where it's all worth it. Okay, going back here, we have our material. This is the material. Oh, I haven't assigned the material. Let me assign the material. The material is now assigned. Going back. I also need that should... Yeah, okay, as I am adding things here, let's assume that doing it here will work. Okay, I also have the material, which is the Greenery item material. Set buffer. I need to set the triangle buffer, the draw triangle line buffer, to the thing that we just generated. So draw triangles buffer needs to be the draw triangles buffer after we have dispatched the shader. No need to set anything else right now on our material. All the rest is just fluff for the visual style. We're getting close. I can almost taste it. So this is where the magic happens. Graphics. Draw, procedural, indirect. Oh, I guess keep it like that for now, but we're gonna have to instantiate the material too, because we're passing a buffer over to that material. So again, if we have the same material on a different set of grass that's using the same settings, we will have like a different draw triangles buffer in it. So it's gonna be a different material. But for now, let's just hope that this works with this one. So Greenery item material, we have the material. Bounds, we have the bounds. Mesh topology, we have that. It's triangles. I mean, even if we weren't just outputting one triangle, it was gonna be triangles. The arc buffer, we have that. Direct arc buffer. Arc offset, 0. Camera, no, we don't care about that. Material property blocks. That's actually a way to not having to instantiate our material, but for now, keep it null. Shadow casting mode. Okay, whatever. Shadow casting mode off for now. Receive shadows. False. layer. Let's add it over to the Greenery manager game of layer, no, game object layer. This is it. This is it. Can I get like brain hands and fingers in the chat? Because this is it. If I change over to the Unity view now, either things will break or we will see triangles. I'm gonna pray for us. Let's see. Victory. Breaking victory. Not sure why it's not updating though. That's alarming. Okay, we saw some triangles, but we're not seeing them anymore, so that's a bit annoying. Let's do that. Update data every time. Release buffer and set up the buffers again. And also, yeah, you know what? If the spawn data list count is lesser or equal than 0, then, you know, kinda don't render anything, you know? Okay. Also, we don't need this. Okay, why is it doing it now, but not when I'm adding points? Because, you know, that was kind of the deal, you know, Whoa. Oh, yeah, so date, you know, if the circle count, do that if you actually have data to use, you know, not so, sorry, spawn data list. Okay, we're still scattering the points and we kinda see why does it do it only on enable? What's because it updates the renderers. Let's humor this and update the renderers. Again, this is obviously not gonna happen at every frame. Why are you not updating though? We have the triangles, but when I'm adding things, things don't work. Okay, so don't do this here. Let's see what's up with that. Set the data. And the kernel. This is Greenery render, late update. Should I also say execute always? No, doesn't make sense. I mean, it's just a class, it's not even a mono behavior. Why? Is it because it's like a late update? If I add it on proper update? Hey Mathis, we can see triangles. Yay, and also, if I increase this, yeah, you see they get updated and all that crap. But the thing is, when I'm adding things, they disappear. When I toggle the manager, they reappear. But yeah, we have triangles. Like this is exciting. And the colors are proper too, like they're exactly as I set them. Actually, they're the other way around. I think I messed up the winding order. Should it be clockwise or counterclockwise? Because the first vertex I added was red. Like you can see here. Yeah, the vertex color, dude. Yeah, the first one. Okay, let's do it. Counterclockwise? I mean, right now I'm like bottom left, bottom right, top. So it's counterclockwise. Needs to be clockwise. So like this. Yeah, this is more correct, I think. Yeah, this is yeah, they were pressing the wrong way before. This is how they should look. But still, they don't get updated when I'm painting stuff, and that's annoying. Maybe I'm missing something. So when I'm adding the data, I add the spawn data. And I inverse that, whatever, and I add the spawn point. Are they going to always face the camera? Not necessarily. So the thing is that the goal of this is to make it modular enough so you can, with some boilerplate libraries, create whatever grass you want. So, you know, if you want it to be billboard, then you can. You can either do that in the compute shader or in the actual vertex shader. So you can make them face the camera. You can actually have them be, you know, blades with like a curve and all that crap if you want. They could be like the star formation with quads. I am gonna make different versions just because I have fun making these. But the point is that you would be able to extend the greenery item scriptable object and like inherit from it and make whatever geometry you want. So yeah. Okay, so the renderer. I'm adding a spawn point, adding it to the list, update the freaking data. Update the data. I'm doing the cell binning, I'm releasing the buffers, I'm setting up the buffers. But again, the render, is it called on every frame as it should? No.
Liftoff of mission 41B, the first flight of the orbital Discovery, and the shuttle has cleared the tower. Discovery's core computers now have primary control of critical vehicle functions.
Execute always should make it execute always, right? Why is update not being called on every frame? Supposed to execute always. We could always update. Am I doing something like so wrong? It says here, execute always. I mean, this it knows that to do in edit mode. Why not call update too? What's wrong with you? Is it because I have like the serializable thing? But this shouldn't matter. Okay, what if I hit play? Okay, the update is running. Why you cannot be null? This is a classic one. It's not about this being here, I guess. So just keep it here for now. I am gonna make it better. I just want to see it playing, working in play mode. Oh! Squeeze me. Okay, working now. Hitting play. Not working now. Why you cannot be null? You are killing me. Direct arcs, but it's not null. Is it the buffer that it's not? No, it's not null. Set it in direct arcs. You want me to serialize it, bro? I can serialize it. It's called when values change by default. To get an update every frame, you need to add callback to editor application update. That shouldn't be the case. Editor application update. But it's not an editor update, it's a normal update, but I'm, telling the script to execute always, so it should execute always, That's how, Joyce also has it in her script. It's all rendering in late update, and yeah, there's a execute on edit mode. In edit mode tag that should tell it that when to render, but yeah, clear all points. The render sheet under play mode be annoying. Why can't you? Public. Yeah. 0 points. You can see I have the clone of the compute shader here. Rendering, entering. The clone is still there, exiting. Okay, it's playing on edit mode. That's cool. And the triangles stick because the rendering compute shader isn't going anywhere. But what's up with this? What's up with this? Is it because of... Let me check my other implementation of this, because this is getting annoying. We're so close. Nope, should be the exact same thing. Update. When is it calling the update? It's on enable and disable update. Yeah, it's on update. It's on freaking update. Why do you hate me? Like, okay, screw that for a bit. I need to just like check the simplest thing. Wait. Execute always. Please execute always. Add it to an empty object, I don't care. This is very suspicious. Okay, try executing edit mode. When render, oh my god, That makes so much sense, yeah, because here's the thing. I have tried using this approach so weird. I've tried using this approach on HDRP, and apparently there something changed every frame and causes stuff to redraw because of the way it's set up. Okay, I want to try this for now. Okay, this works. On render object, okay, test update, yeet, alright. So if instead of update, I just use the on called after camera, it's called after camera has rendered the scene. Yes, I am powerful. I am powerful. Still kinda lagging though. Okay, for sure I don't need to update the data here. So instead I'm gonna change the editor and update the data manually. At one point here after the loop. Yeah. Data. Okay, for each. What's your first check? What changes? Oh, that's a good question, and I will check it out actually because yeah, I'll check it out. Selected item. Big data. Okay, do this. Here too. I guess. Always refresh was not on, to be honest, so let's try. Oh, wrong thing. Okay. No, doesn't work. It needs the on render object thing. Okay. Triangles right now are not following the direction. Whoa! Okay, streaming doesn't like my instances. That's fun. Okay. That's something that happens when I play around with grass and stuff like that, which is annoying, especially for this series, which is like focused around instancing, and yeah. I don't know if it's because like there's CPU strain from the streaming and whatnot. Yeah. Also, you know what? Update the data. No. Oh, sorry. Clear spawn points. Yeah, let's update the data. Why didn't it though? Clear spawn points. Like clear points doesn't clean up. We got a cross! Of course. As I mentioned, working with compute shaders can be dangerous. And things are not working now. The object I'm trying. Oh yeah, it's because it didn't keep any data here. Shadows, triangle. Yeah, clear points. No, still not in the mood to draw anything. That's upsetting. Oh, no. Oh, I'm an idiot. Wait, oh no, I'm not an idiot. Why is it not working now? Come on! Paint something! You have the compute shader, you have the material. Oh. Yeah, okay, we're back on track. Kinda. Okay, and it's not lagging so much, I believe. Yeah, there might be some kind of memory leak thing that makes it lag after a bit. Yeah, the stream is not having a great time with this. That's for sure. Not sure why it's not updating properly. Like a lot with tracking done it, so like, yeah, well, in this case, it's not a mystery to have like editor lag. Okay. Yeah. It's dropping some frames, alright? Okay. Clear spawn points. Clear the spawn points. Data. All but at least clear. I'm not keeping anything I shouldn't, right? You know what? Update the data and release the buffers, maybe. Okay, so one optimization that can be done for sure here. Yeah, one optimization that can be done for sure is making sure that I don't destroy and recreate the buffers again and again in every frame. That shouldn't happen. That should actually only happen if I am updating my data, because the buffers, you know, essentially they won't be changing. Notice that messing with GPU resources on computer can cause weird lag crashes depending on how good the graphics driver are. Recovering from leaked buffer. Yeah. Again, maybe, well, definitely right now my code is not perfect, especially in terms of resource management. But yeah. I will have to look into that and looking into better buffer management and better data management, and looking into all the weird lag. But the cool thing is we have things working. Let me reset all the stuffs just so that I can see them working. Clear all items again. Okay, so a first thing, some checks that I can make is, okay, if I have no spawn data list, don't do anything. If a greenery manager, greenery item material is no, don't do anything. If the if the rendering CS is no, don't do anything. And I should move that here. Okay, we're back where we were, saving shit. If I hit play, I see my stuff, kinda. Not sure why they're not rendering for me here. But they're updating there. I think it has to do with the on-render object thing. So I'm kind of okay with this. I can still change the width and height. Whee. And yeah, we're onto something here. Whoa. Might have to investigate that. But we have triangles. So yeah, I'm gonna I think I'm gonna leave it here. Yeah, that was almost. Yeah, I think I was actually right about the time before. It's almost been like 2 hours since I started streaming, and I had the computer set ready at around 40 minutes, and the rest of the time was setting everything else up. But it kind of works. So, yay. Maybe something with this, something. I don't know. I have to look into that. But yeah, I probably won't work on it anymore today. I got it all out of my system. I just wanted to see a freaking triangle on my screen, and I have all the groundwork for it to make it work. So I think after that the fun begins, and we can. Well, first of all, I will try and see why it crashes and make a better management of my resources. Maybe, hopefully, it won't lag so much, especially while streaming. Well, actually, the weird thing is that it's not lagging while I'm streaming, but it causes the stream to lag, which is super annoying. But yeah. Yeah, after I get all the data management and everything and the crashes back on track, I think we can get over to the fun part, which is making cooler looking grass, making different ways of scattering points, making quad grass, adding wind, playing around with a shader for in order to make it look cooler, and yeah, other cool stuff like that. So yeah, actually making this from scratch in its simplest version, it gave me a really much better understanding of how this thing how it works and how we can play around with other geometry and how to add more interesting stuff. Yeah, we can play around with the normal vectors and have the instances use the normals of the terrain for shading so that they look uniform, but their own normals for fake subsurface scattering, so you can have light coming through. I mean, we can do a whole bunch of stuff. But yeah, from here on out, it's mostly fun stuff. Hopefully. And maybe just maybe I will finally have a grass system that I can use everywhere. Without having to change the internal scripts per project, and yeah, it should fit all of my needs, and hopefully it will also be useful for anyone that wants to try it out and even maybe contribute to it and make the code better, because I know that this can be done. Until then, I'll just do some more streams on it. Next one should be on Tuesday. Hopefully I won't be hyper focusing on this again tomorrow. I mean, I have work to do, so hopefully not. And yeah, if all goes well, see you on Tuesday, where we will have some more fun with this. Well, thanks, Drewfish. I'm really glad you enjoyed it. And yeah, I'll see you in the next stream then.